Hey there, how's it going everybody? In this video, we'll be learning how to import modules. We'll start by importing modules that we've written, and then we'll explore a bit of the standard library and how we can import those modules to solve a lot of common problems. So I have a module here called mymodule.py. Now, within this module, we have a print statement, and we'll talk about that in just a minute. We also have this test variable set to test string, and then we have this function called findIndex. And this findIndex function takes in two arguments. It takes in a list to search and a target that we're looking for. And we can see that we have some documentation here that just says that this finds the index of a value in a sequence, and then it returns that index. But if it doesn't find that value, then it just returns -1. So let's say that we wrote this function and that we want to use this in other modules or scripts. So what we're going to want to do is import this. So I have another module over here, which is just our intro.py file that we've been working with. Now within this file, we have this courses variable that is just a list of course names. So let's say that we want to use that findIndex function from my module. Now, I actually created this my module in the same directory as my intro.py. So that means that we're going to be able to directly import that. Now, when we import a file, it actually runs all of the code from the module that we import. So that's how it creates all of the functions and variables. But if we have any other code like print statements or anything like that, then that will be run as well. So that's why I have the print statement here in my module so that we can see when that happens. So to import this module, we can just come to the top of the file here and say import my module. And again, we can import that directly because it's in the same directory as our intro.py file. And now if we run this with this import, then we can see that it imported successfully because it printed out that print statement within that module. Okay, so let's say that we want to use that findIndex function. Now, when importing modules like this, we just can't call our findIndex function. We instead have to type the module name first, and then what we want to grab from that module. So if we wanted to use that, then we could say, let's say index is equal to my module dot find index, and now we'll pass in the list that we want to search, which is courses, and now the target that we're looking for. So we'll go ahead and say that we're looking for math. And now let's print out that index and run that. So now we can see that that works. It returned 1, and 1 is the index of the math value. Okay, so if we're using this findIndex function multiple times throughout our script, then it might get a little old and take up a lot of room to keep typing mymodule.findIndex everywhere. We can actually specify a name that we want to use for our imported module, and usually this is used to make the module name shorter. So for example, when we're importing my module here at the top, we could instead say import my module as MM or any other name that we come up with. And now when using this import throughout the script, instead of typing out my module everywhere, we can instead just use MM. So if I save that and run it, then we'll see that that still works. Now you'll see this a lot with modules like NumPy or Pandas. So you might see someone who does an import and they'll do import NumPy as NP or something like that. Now you might be wondering if there's a way that we can import the function itself, and there is a way to do this. So instead we could say from my module import, and then what we want to import from that module. So we want to import findIndex. So now when we use this throughout the code, now we can just use that findIndex function anywhere, and that really cuts down on the typing. So now we can save that and run it and see that it still works. Now, one thing to note about that approach is that it only gives us access to that findIndex function and not everything else in the module. So for example, you'll remember that we had this test variable equal to this test string. So when we do the import this way, now we don't have access to that test variable since we're only now importing the findIndex function. Now, if we wanted to import that variable, then we would have to include it by putting in a comma and then specifying what we want. So we want to say from my module, import findIndex, comma, and test. So now down below here, we can print out that test variable, and if we run that, and we can see that we do have access to that test variable now. Now, when doing the import this way, we still have access to that as keyword. So if we wanted to make this even shorterhand, then we can say import findIndex as fi. And now throughout our code, we can replace that with fi and run that. You can see that it still works. Now, at this point, that's not really readable anymore, so don't rename something like that unless it's still readable and makes sense to others who are reading your code. So now let's go ahead and just undo that change. Now, using this method of importing, we'd have to add commas and specify each value that we want to import. Now, there is a way to just import everything, and I'll show you how to do this, but I have to be honest, I never use this, and it's pretty frowned upon, and we'll see why that is. But if we wanted to just import everything, then we could say from my module, import star. So if we run this, then we can see that everything still works. We still have access to this find index function and this test variable. But the reason that this is frowned upon is because now we can't tell what came from that imported module and what didn't. So if we're having problems with this find index function, then we might try to track down where that function came from or where it was defined. And with that asterisk, it's just not obvious that it came from that module that was imported. So instead, we'll go back to importing both of those directly. So basically importing everything with that asterisk just makes it harder to track down problems. So it's better to do it this way. Okay, so when we import a module, how does it know where to find this module? So we didn't pass in a file path or tell Python where to find this module, it just found it. So the way that this works is that when we import a module, it checks multiple locations, and the locations that it checks is within a list called sys.path. And we can actually see this list if we import the sys module. So I'll import sys, and now down here we'll comment out these two print statements. And now let's print out that sys.path and run that. So this is the list of directories on my machine where Python looks for modules when we run an import, and it looks in this order. Now, this first value here is just the directory where I'm currently running the script from. And the my module Python file that we were importing is within that directory also, so that's how it found it. Okay, so what directories are added to this sys.path list? So directories get added in this order. First, the directory containing the script that we're running. So that is why this directory where we're running the script is the first value in sys.path. So you can always import modules from the same directory. And next, it adds directories listed in the Python path environment variable. And we'll talk more about the Python path environment variable in just a minute. And then after the Python path, it then adds the standard library directories, and that's how we can import those modules from the standard library. And lastly, it adds the site packages directory for third-party packages, and we'll look at all of these. So first, let's see what it looks like when the module that we want to import isn't in the same directory as the script that we're trying to import it from. So I'm going to move the module that we've been importing from the same directory into a directory on our desktop. So I've got Finder pulled up here, and I'm just going to drag this my module over here into this my modules directory that is on my desktop. So now that module that we're trying to import is in a completely different location on our machine. So if we go back to here to our script and now try to run this, then we can see that we get this error, module not found, no module named my module. Now there are a couple of approaches that we can take here. First is that we can actually manually add that directory to our sys.path list. So this sys.path is a list just like any other that we've been looking at, and we can treat it like one. So before we try to import my module, we could add that directory to sys.path. So I'm going to import this here at the top before we try to import that module. And then I'll say sys.path.append. And the location on my machine, this is probably going to be different on yours, but the location on mine is users-corey-desktop-my modules. And I believe I need a dash here at the beginning as well. So if I save that and run it, we can see that when we appended that directory to our sys.path, that we were now able to import that module and run our code. But this isn't the best looking approach because we're appending this directory before our other imports. And also, if we were to import our module and we had this manually hard-coded in multiple locations, then we'd have to change all of those. So instead, we can make this change in the next place sys.path looks. And if we remember, that is the Python path environment variable. Now, changing the environment variables is different on Mac and Windows, so we'll show how to do this on both really quick. So first we'll see how to do this on a Mac. And to do this, I'm going to pull up my terminal, and we can set environment variables by adding them to the .bash_profile file in our home directory. And you can edit this file with any text editor, but I'm going to use the one built into the terminal here called Nano, since Nano is easy for anyone to use. So we're going to say nano, and then a tilde dash just makes sure that we're working within our home directory. Then we'll say .bash_profile. Now, I might have more stuff in this file than you do. These are just personal preferences and customizations, but I'm going to scroll down here to the end of the file and set my Python path, but you can set this anywhere in this file that you'd like. So we're going to set this by saying export Python path, all uppercase, and then equals. And now we want to set that location. So I'm just going to come over here and grab that location and paste that in those quotes. And we want it to look just like that, no space in between the equals and the path. So to save that, we can just hit Control X and then Y to save, and then Enter to keep the same file name. And now we can either restart our terminal or run a source command on that file, but I'll just restart the terminal here and pull this up. And now if we run Python, then let's see if we can import that module. So import my module. And we can see that that worked. And the reason that that worked is because if we import sys and look at our sys.path, then we can see that after our current directory that we have the directory that was added there. And the reason that it's added is because we added it to our Python path environment variable. So now let's take a look at how to set this environment variable on Windows. Now to set this environment variable on Windows, we can click on our Start button here, and then right-click on Computer and go to Properties. And from Properties, we want to go to Advanced System Settings. And from here, at the very bottom, we can click on Environment Variables. And now we can create a new environment variable. So we'll click New, and we'll name this Python Path, all uppercase there. And then for the location, that's going to be C. We're going to go to the desktop again. So again, this is specific to my desktop, but it may be a little bit different on yours. So Corey MS/desktop, and then the name of that directory is my-modules. And again, this Python path is going to be unique to your own machine. So let's hit OK there and OK to save those and exit out of that. And now if we open up our command prompt by going to Start Run CMD, and then typing in Python. And now we should be able to import that module just by saying import my module. And if we run that, then we can see that it imported that module successfully. Now the reason that worked is because if we import sys and look at our sys.path, then after our current directory, you can see that our directory that we added to our Python path is the second one that it looks at here. So that is how we add that environment variable on Windows. So now I'll switch back to my native OS. Now, I do want to point out that if you're using an editor like Sublime Text or Eclipse or PyCharm, then these may need to have their environment variables set in a different way. And that's different for every program. So instead of going through each individual one and showing how, you can likely find out how to do that just by searching for your editor plus Python path. And there should be plenty of resources showing you how to do that. Okay, so going back to this sys.path. Now, after the directories in the Python path environment variable that we just looked at, after that, sys.path looks at the standard library directories. Now, this is what allows us to import modules directly from the standard library. So when something is part of the standard library, it means that we're able to use it without installing anything separately. So the standard library is incredibly useful because if you're performing a common task, then most likely someone has already written the functionality. And if we use it from the standard library, then we can be sure that it's been written by some of the best programmers in the world and has been optimized to be as performant as possible. Now, that's not to say that you shouldn't try to write your own versions of some of these things just to get some practice, but as far as using any of that functionality in production, it's probably a good idea to use the tried and true standard library. So, for example, let's say that we wanted to grab a random value from a list of values. So you could probably write something to do this on your own, but that functionality is already available to us when we use the random module from the standard library. So let's go ahead and take a look at this. So I'll get rid of everything here just to clean up, except for our courses list. Now this random module is just part of the standard library, and we can just say import random. And if we wanted to grab a random value from our courses list, then we could just say random course is equal to random.choice, and then pass in our courses list. So now if we print out that random course and run that, then we can see it gave us a random value. And if we run this multiple times, then we can see that it gives us a random value just about every time we run through. Now, I'm not going to go through all of the functionality in the standard library, but I will create a future video to go over some of these modules in depth. But right now, I just want to give you an idea of what's available to us. So here are a few more useful standard library modules. So if we need to perform some common mathematical operations, then we can import the math module. And now we can do some mathematic calculations. So if we needed to convert 90 degrees into radians, then we could say rads is equal to math.radians and pass in 90. And then if we print rads and run that, then we can see that we get that conversion. And if we wanted to get the sign of that value, then we could pass those radians into the sign method. So I can say math.sign, pass in those radians, and if I run that, then we can see that 1 is the sine of 90 degrees. Okay, and another useful module from the standard library is the datetime module. Now this allows us to work with dates and times. And while we're at it, let's also go ahead and import the calendar module. Now these have some similarities, but they're also very different. So for example, if I wanted today's date, then we could just say today is equal to datetime.date.today. And if we print this out and run that, then we can see that that gives us today's date. Now with the calendar module, we can ask, for example, is 2017 a leap year? So I could print out and say calendar.isLeap and pass in 2017. If I run that, we can see that that's false. But if I instead change that to 2020 and run that, then you can see that that is true. And the last standard library module that we'll look at for now is the OS module. So I will import OS. Now this is going to give us access to the underlying operating system. So for example, if I wanted to see what directory we're currently in with this script, then I could print out os.getcwd, which is current working directory. So if we run that, then we can see that it prints out the current working directory where this script is located. Now this OS module has a ton of other functionality. It gives us the ability to scan the file system and create files, delete files, and all of that. So you can see how these standard library modules provide a ton of functionality that might be tricky or take forever for us to write ourselves. So Python comes with a ton of stuff available to us and makes it super easy to get them imported and running. So another great thing about Python is that these modules are just Python files themselves, and we can view the location of a module just by printing out its dunder file method. Or its dunder file attribute, I'm sorry. So if we print out os.dunder file, and dunder just means 2 underscores. And don't worry why those are double underscores. That'll be a topic for a future video. So if we run this, then we can see that it prints out the location of this file on our file system. And if we open up that Python directory where that file lives, then we could see the entire standard library. So I actually have this open right here. So let me open this up real quick. So I actually have open that Python 3.6 directory where the entire standard library lives. Now, I know that this may be a little small over here for you to see on my screen, but let's go ahead and look through a couple of these files. So these are all in alphabetical order. So one of the first files in the standard library is actually this anti-gravity module. Now this is kind of a joke in the Python community. So this is a module that you can import called anti-gravity that will open up a webcomic on your machine. And even though this is part of the standard library, we can just open up this module here and see exactly how this is done. So we can see that basically it just imports this web browser module and opens up the web browser to this page here. And I know that people are probably going to be curious what this comic is now, so let's go ahead and import that. So back in intro.py, I'll just delete everything and do import anti-gravity and run this file. Then we can see it just opens up our web browser to this comic, and I'll leave this open while we close out here. So if you get a chance, then don't be afraid to go into the standard library and look around at how different things are done. It's a great way to learn. Now, I'm not going to lie, there's definitely some complicated code in there, but you'll be surprised how much you can understand if you just poke around a bit. Okay, so I think that's going to do it for this video. So where do we go from here? So far in this series, we've covered a lot of the fundamentals in working with Python. So we've learned about different data types, conditionals, loops, functions, and importing modules, and a bit of the standard library. Now, I think that just about anyone would agree that no matter what specialty you plan on going into for Python, whether it's back-end web development, data science, building desktop applications, no matter what route you decide to take, you're going to need the fundamentals that we've covered up until this point. But now that you understand these fundamentals, the next topics that you learn are up to you. So you can jump into learning object-oriented programming in Python. You can learn how to work with files and file data, start learning about a web framework, basically anything that you want. So I'm going to keep adding additional videos onto this playlist that I believe will be a good progression as you continue to learn Python, but these videos won't be numbered anymore after this video. And the reason for that is that I don't want to give the impression that you have to watch one before understanding the others. So I don't want them to be numbered to make you feel like you have to understand virtual environments before learning how to work with file objects or something like that. So you can just skip around depending on what it is that you're wanting to learn. So I hope that that makes sense. Now, if anyone has any questions about what we covered in this video, then feel free to ask in the comment section below, and I'll do my best to answer those. If you enjoy these tutorials and would like to support them, then there are several ways you can do that. The easiest way is to simply like the video and give it a thumbs up. And also, it's a huge help to share these videos with anyone who you think would find them useful. And if you have the means, you can contribute through Patreon, and there's a link to that page in the description section below. Be sure to subscribe for future videos, and thank you all for watching.